Today, we so far have been discussing how to make equations of lines. We've done a little graphing, a bit in there. Now, today our main focus is going to be on graphing, except we're going to have multiple lines that are working instead. So, just going to be dealing with parallel today. So, parallel lines never cross because they have the same slope. So let's kind of put that to the test here. Line AB, remember when we're doing slope, rise over run. So when I'm trying to figure this out, let's say for AB, I got to say, okay, to get from A to B, we got to use the regular roads, no cutting. So I go and I go up 1, 2, 3, 4. So that's plus 4. And then from there I go right 1, 2, 3. Rise over run. And if I do the same thing for CD, so okay, let me just kind of follow it. 1, 2, 3, 4. Up. And 1, 2, 3 to the right. I get the same thing. So for two lines to never cross, the only way that occurs is that they have the same slope, whether it's a whole number, a fraction, whatever that happens to be. So, oh boy. Example, write the equation of a line, oh, here we come to this again, we may have to refer back, that is parallel to the line y equals 3x minus 1, but goes to the point 5, negative 2. Okay, so just from the information here, it's parallel, there's the slope of my other line. So my slope for this new line has to be the same. It also has to be 3. And then they've given me this point, 5, negative 2, which I know would be my x1 and y1, because remember, when I'm plugging it into my equation from what we were doing for the past couple of days, here are the 3 places that I have to plug numbers in to make this equation. And I have all 3 of them. I've got m, and there's my x1 and y1 right there. So it's straight up just going to be substitution. So, let's go for it. So y minus, okay, right, y minus negative 2, you're right, is going to make that plus. I always like to think of it, if you take a minus and you take a negative, and you turn the 1, it turns into a plus anyway. So y plus 2 equals m x minus x1. Okay, I do have to be careful with my signs because those minuses are always part of what we're doing. So once I get it plugged in, I am not done, because when it says write the equation of a line, we want to get it into slope-intercept form, because if I am asked to graph it at some point, and I will be, I want to be able to have it in a form that I'm used to graphing in. So, to get it in that form, we're going to distribute our 3, because we need the parentheses to go away. So 3 times x is 3x. 3 times -5 is -15. And now to get it into this form, I just need y by itself. So what's my one step I got to do to get y alone? We just got to minus that 2. And again, this is just a number. It does not have x. Do not put it under the 3x. That will not help us. Thank goodness I don't have to graph that. That'd be a long ways down to get to my y-intercept. But that's all there is to this. So whether I have a picture and I'm trying to figure out the slope of the other line, they have to be the same. Or I'm given an equation and I'm told, hey, this line is parallel. That tells me whatever number is in front of x, that's what my slope is going to be for my other line as well. So what we're going to do then, and I'll keep referring back to this, is we're going to take a peek. We're not doing perpendicular today. I'm breaking it up into pieces. Yeah, I'm going to break it into pieces. And so today we're going to lock in on parallel. So determine whether the graphs of the following equations are parallel. Explain. So again, all we're looking for here is, are they the same slope? There is no math to be done here. All we have to do is look at each of these two y= equations. Look at the number. Look at the number in front of x, but we have to be careful at the same time. We're going to learn that here right off the top on this first one. Okay, so here my m is 5. Yeah, what's 10 divided by 2? 5. So, yes, these are parallel. Because they have the same slope. But here's the part where I have to be a little bit cautious, because there's going to be little things that can throw this off. So let's say, for instance, I'm doing number 4. And I get down to number 4, and I'm like, okay, well, this isn't bad. And I'm going along. Don't box in that 2. You're like, why not? Because this equation isn't in y= yet. Ooh. So let's make a little note. We're going to make sure the equation is in y= form before we figure out the slope. Because if I just put a box around the number in front of x right now, I'd say it was 2, and I'm like, nope, these aren't the same. But maybe, since I have to work on getting y by itself first, and I'm multiplying it by 3, what's the opposite of multiplying by 3? I know y'all know this. I heard it. What's the opposite of multiplying by 3? Dividing. So if I divide everything by 3, once we're in y=, now I can look at that number in front of x. And I look, and I'm like, oh, well, m is 2/3, because that's the number in front of x. M is 2/3, because that's the number in front of x. These are going to be parallel. They have the same slope. Like, okay, So what would be a situation that wouldn't work? I give you number 5. So I look and I go, okay, that's in y equals. Got my m. Cool. Y is not by itself yet in the second equation. So, how do I undo plus 4x? Subtract it. And when we're rewriting these, we always want to put the x term first. You're like, okay, why is it important that I do it like this and I don't just put 12 minus 4x? Which is a legitimate question because a lot of times it doesn't matter. Here's the thing. When we're trying to figure out where the slope is, we're always looking for the number in front of x, and we normally see that that's right in front of the equals. If you were to write this as y equals 12 minus 4x, it's going to be real easy out of habit to say, oh, it's the first number after equals, the m is 12. No, it's not. So that's why we don't want to do that. We want this. So I box that in, and I go, okay, so the m is negative 4. Is 4 and negative 4 the same thing? Nope. It can be something as slight as the sign on your number. Now, the numbers may be completely different. You may get one is 4 and one is 2/5. It would be. It would be. So it can be a sign, it can be they're completely different. But you do have to pay attention to it. And make sure that you're in y equals before you start. So, let's play this along a little further. Let's actually have to do a little work. So we're doing some plans on our tree house. This is one of the type things they're doing is they're building in the back too, probably in a little higher tech of a way. A beam represented by QR has these two endpoints. A connecting beam represented by ST, okay, has endpoints of these two. Are the beams parallel? Now you're like, what's the big deal with that? For those of you at home, sorry, you're not going to be able to see this. So I got these two beams that I'm using that are going to hold up the roof of my treehouse. It's kind of important that they're parallel because if they're not, it means that at least one of my walls, or not both of them, is already shifting and is probably going to fall over at some point. I wouldn't want to be in the treehouse when this falls over. So we got to make sure they're parallel. So I got my 2 points for QR. So I'm going to label them with my x1 and my x2. My y1 and my y2, just like we've been doing all along. Because again, I remember that when I'm trying to find slope, if I follow that formula, y2 minus y1 and x2 minus x1 with the reminder that when I'm subtracting, either I need to remember that minus and negative is plus, or to be honest, I mean, couldn't I just put it in my calculator? -1 minus -6? Yeah, I could. Oops. Ooh, excuse me.
What?
Thank you. Okay. Slope of my first line, it's a fraction. Fractions are okay. It's probably easier to tell that way anyway. We just don't want to go decimal. So now I'm going to test this out. And I'm going to do the same thing. I'm going to label my x1 and my x2. My y1 and my y2. Plug it into the formula. 0 minus 6 and negative 8 minus negative 3. So let's see here. 0 minus 6 is negative 6. Negative 8 plus 3, or negative 8 minus negative 3, is negative 5. Be careful. Yes. First you're like, nope, they're not the same. But remember, negative divided by negative is positive. These are parallel. They have the same slope. That's how we take the general that we're learning about and use it for something that applies somewhere. Again, you don't want somebody building your building that doesn't understand this concept, or people could die. I mean, seriously, they could. There have been lots of videos out about places. A couple of years back, there was a bridge in Minneapolis, Minnesota that's very busy that collapsed. Yeah, with cars going along. Many people died because they went back and looked at the engineering. The engineering of the bridge had been off very slightly, but it took enough pressure that it just collapsed. So this is stuff, people, that you're like, oh my gosh, Hardy, you're back to this again? Yes. Yes. Okay. I want to take a peek at 10 since it has directions, because it kind of takes us back to what we were doing yesterday and mixes in today as well. So reminders of a couple of things. Let me get my labels in on my point. Write an equation in slope-intercept form. So remember, the end goal is to get it into y equals. It's parallel, which means whatever the slope is of the line they give us, that's what we're using. Okay? And now it just becomes, like it has been all along, we've got this on our notes, I'm hoping, at this point, but if not, we're going to still do it here. Y minus my y1, which is negative 2, but minus a negative becomes plus. That won't be true every time, but it seems to happen a lot. Equals m, my slope, x minus x1, but minus a negative, again, becomes plus. Now, myself, I'm going to rewrite this for a minute so it looks a little more normal. Because with all those pluses and minuses, that can confuse me a little bit. So I get those put in. And I'm going to distribute that negative through, just like we've been doing on the rest of these. And so even though when we get done with this one, the rest of the problems on this page don't have A, B, and C, this is the exact steps you're going to use. So you're going to have something directly there. And just like we were saying at the start of this problem, the goal is to get y by itself. So just undo the one thing that we're doing to y. Y equals 3x. 3 minus 2 is 1. And I'm there. And I already know a couple of the questions that are going to come up. So I'm going to keep rolling for a minute because, like I said, I know what's going to happen here. Because I think the next question I'm going to be asked by somebody is, well, wait a minute, though. On 11 or 13, that's a fraction. I don't like that, so what am I going to do? Okay, let's deal with it. Let's do 13. That looks kind of interesting. And it also lets us work through one of the problems where we don't have ABC there, so we can do it ourselves. So, okay, we're going to do the same stuff, though. X1, Y1. And now, those are the three things we need, because those are the three things we got to be able to plug in. So, here we go. Y minus Y1 equals M X minus X1, which is -3, which is going to make that plus. Here's the best news about this problem. Y minus 0 is just Y. So when we're done with our distributing, we're going to be done. 2/3 times X is 2/3 X. Yeah, but Hardy, I don't like this part with the fraction. We got this. Okay. 2/3 in parentheses times 3. That's it. I'm done. And there's even one on here. It's going to try and fool us, but we ain't going to get fooled. I look at number 15 and I start doing my thing. This is the last one I'm going to do. So I'm labeling all my stuff and I'm going along. And I'm like, wait a minute. Hardy, there's no X here. How do I find my slope? Oh, wait a minute. Reminder. When my equation is just y equals in a number, my slope is going to be 0. So I'm going to work through this because I'm going to pretend for a moment that I'm not sure what I'm doing, but I'm going to show you a shortcut. So stick with me through here. So you're like, okay, I'm going to go in and I'm going to do my thing, Hardy. Let's do this. So you're like, okay, so the slope is 0. Got it. Y minus Y1 equals M X minus X1. Just following that same pattern we had in number 10. So I'm doing my thing here, and I'm like, okay, so y minus 4, I'm going to distribute my 0. I'm like, wait a minute, Hardy. If I multiply something by 0, it's 0. Like, that's gone. There's no x, there's no 2. Okay. What's my last step to get y alone? I'm going to add 4, but here's the thing. I didn't have to put myself through all of that. We actually talked about this yesterday because if that's just y equals, go over to your coordinate point and put y equals. You're done. So let's just say, for example, so now that you've seen that, let's say Hardy was to put a question on that looks like this and said, hey, make the equation of the line parallel. Instead of doing all this, but you still could, it'll get you to the right answer. You could just write down y equals, oh, there's the y of my equation, and write it. that will work. It only works, though, if the slope is 0. If it's y equals in a number. So don't think that's the answer every time. It's going to be rare. Most of the time, we got to work through the whole step. But sometimes we get luck if we're paying attention. So your job is to knock out the other, like 5 or 6 problems we've got on this sheet, okay? And then when we get back together Monday, I'll have decided which route we're going. But again, no quiz next week. But I still would say get some of these done to make sure the lesson sticks in your head. Because if you do none of them right now, if you go just to your weapon of mass distraction for the rest of the time, if you haven't been already, this isn't going to stick, and then it's not going to look good. And it's not going to look good for this or your grade. So I'm just saying, do a good thing.